Hey, hello everyone. Let's look into today's contest question of Paint House 4. You are given it an even integer array of size and representing the number of houses arranged in a straight line and a two-dimensional array cost of size ending to 3, where cost of I of j represents the cost of painting house I with color j plus 1. Okay. The houses will be beautiful if they satisfy the following conditions. What are the conditions? No two adjacent houses are painted the same color. This house and this house adjacent houses should not be of same color, and houses equidistant from the end of the row are not painted the same color, and which are equidistant from the ends also should not be painted the same. For example, if n equals to 6, the houses at position 0, 5, 1, 4, 2, 3 are considered equidistant. That's okay. Return minimum cost of painting the houses. And they look beautiful. Okay. Now let's look into question. Let's understand the question. What's a given? Yeah, we are given with an integer n, which is of even. This n represents there are n houses in a straight line. Here n is 6. We need to paint these houses. We need to paint these houses, and we are given with 3 different colors. We need to paint these houses in such a way that uh, these two houses, the adjacent houses, should not be of same color, and houses which are equidistant from edges should not be of same color. And for every color we paint, we do have a cost of I of j, which implies that this is house and this is paint. Okay, we need to find out minimum cost. Minimum cost and house should be beautiful. House is beautiful, right? This is what our problem is. So, what could be a favorable approach if we first, when we are having these houses, we first select house at 0th index, paint it, and ask our algorithm to paint the final house from the end, which is equidistant, and paint it. And again, we move on to this house and say you do have this color painted on left, and towards the right, we do have this color painted. For this house, we do not have any effect of this paint. So when we are coloring from this side, we need to consider only color which is painted here towards the left, right? We need not consider what is towards its right color, right side. And we paint a color from all the colors, and we then ask our algorithm to go to the same equidistant position and paint this house. We now update this left color to a color painted here, and right color remains the same. So when painting this house, it should not be, the adjacent color should not be the same, which is it should not be equal to right, and houses which are equidistant from the edges should not be same, and also should not be equal to the left color. So in this way, we design our algorithm such that no two adjacent houses have the same color, and no houses equidistant from edges also have the same color. Right? What we are doing first? We come from the left side, pick a house, color it, and then move on to the house which is equidistant as of left from the right, and color it, and then move on to next index which is very next to the previous house painted. We paint it and move on to house which is equidistant, and then paint this house. In this way, when would our algorithm stop? After how painting this house to the very mid between, and finally we paint this house which is n by 2. But since n by 2 plus 1, uh, but since we are using 0 indexing, it would be n by 2. The position of this house would be n by 2. So this would be our base case, right? Now looking into code, let's first only consider a DFS approach of this algorithm, and then convert it to DFS plus DP algorithm, right? Okay. Now looking into the coding part of this question, uh, code. This is just a DFS approach where when we start with zeroth index, this would be your upper limit. By upper limit, as I said in the previous explanation, from left we move on to equidistant element on the right, right? So for this half of the array, we move in that way. So to get that half, this is the upper limit for that half, and these are the cost array. This will be your initial left color. This will be your initial right color, and the size of the array of houses is given here. We need to return it in long format. So what long DFS index upper limit cost left color right color and now considering the cost to be maximum value, we need to minimize, right? So we consider it to be maximum value. Then this is the base case where we end our algorithm. That is, as I said earlier, uh, n by 2, right? Here we took our upper limit as n by 2 plus 1. So that add 1 to our upper limit. So here we need to get a minimum cost from all the three colors. So for all three colors, which is it should not be equal to left color and right color, we select a color which is minimum cost and then return the cost of that at the base case. And all other cases when we are towards the left or right, considering this index when less than upper limit. When index is less than upper limit, we are to the left side of the array. So we need to select a color from all the three colors, and it should not be equal to left color. If it is equal to left color, it would be the same adjacent house. It should not be equal to the left color, and we get the cost of painting further plus the cost of selecting this paint at ith index. So this would be your cost. By DFS, we go further and ask on to subpart. This would be the minimum we assign the minimum cost. And for the other part of the problem, it would be same. But here we consider also the right color. And then see the movement of index here. Here from left part, we are moving on to the right part. And minus 1 would be the last index. Minus this index would be give you the equidistant element. And here we are moving from right to the left part, which is size minus present index. We move on to left part and assign the minimum cost here. For this index and further, we will be getting a cost and we return that cost here. This is all of normal DFS approach. If we run it, our code is accepted. And further, if we submit, I hope there should not be any wrong answer, but we get a TLE, I think. What's this? Yeah, it's a TLE, time limit exceeded. So we need to make this DFS approach into a memory optimized. What shall we do? We are now we need to consider the parameters which we are changing for index to index. What are those parameters we are changing? We are changing left color and right color, right? These are the only two parameters we are changing. And also index. We need to keep track of index. It would take you three-dimensional DP, but instead of making it complex, let's using more space. We shall use a hash map to minimize the space we use, right? We are done with our DP approach. We just initialize a DP here, hash map to store a string and the cost. Here is a string in the hash map, index plus left color plus right color will be stored as a key in the hash map. If we have that previous key, we return the cost of that particular index with this left color and this right color. And while after assigning, this is our base case, right? And to the left, after deciding which color to be painted to the house, we put that problem in our DP, and similarly to the right part. Now let's check it. Yeah, we see it's accepted. And if we submit it now, so, yeah, we see the code is submitted successfully. This is what for today's third question.